When we want to write an equation of a line, a really helpful form that we have is slope-intercept form. Y equals mx plus b. And the reason this is so useful to us is because if we can find the slope of a line and the y-intercept, not only can we write an equation, but it makes it easy to graph. If we wanted to graph this, we just had to plot whatever our b is and apply our slope, rise over run, however that worked out. So slope-intercept form, when we have the slope and y-intercept, it's easy to write the equation and then it's easy to graph. But there's also another form of a linear equation called point-slope form. So point-slope form is this: y minus y1 equals m times the quantity x minus x1. Now, although point-slope form isn't as convenient to graphing, it is very useful for when we're given a slope and a point. And it's useful because when we plug our information in here, we can easily switch it to slope-intercept form if we want to graph. Okay, so our point-slope form is y minus y1 equals m times the quantity x minus x1. Again, notice here we have our m. That still represents our slope. And we have our y1 and our x1. That represents a point on your line. So if you're given a slope and a point, you can just plug it into point-slope form, that's where the name came from, and have an equation. So our most common equation, or common form of a linear equation, is y equals mx plus b, but we also have our point-slope form, y minus y1 equals m times the quantity x minus x1. Let's look at an example. This says write an equation of the line in point-slope form. Up until this point, we have been doing two things. We've been looking for our slope, our m, and our y-intercept b, and we are writing things in slope-intercept form. Now, though, we don't need to. We can put it in point-slope form. So let's see how that's done. Our point-slope form is y minus y1 equals m times the quantity x minus x1. For point-slope forms, you need a point, an x1, y1, and a slope, the m. So let's look at this picture here. You can see that we have a line here. That's our the graph of our linear equation. And you can see that we're given our slope, over 2, down 1. So again, finding slope's pretty easy, and we need our slope. In this case, we can use rise over run. And from this point to this point, we're rising -1, and we're running 2. So our slope is -1 over 2. We have our slope. Now we need a point. Well, look right here. We have our point -1, -3. So when you have a slope and a point, you plug things into your point-slope form. Our slope, -1/2. This y stays y, and then we minus our y1. Okay, let me write this down here. We have our slope and we have a point. This is your x1, y1. So we're going to go y minus my y1, which is -3, equals my slope times x minus my x1, which is a -1. Let's get rid of all these minus negatives. If we go keep, change, change, equals -1/2, keep, change, change. There, that's it. That's in point-slope form. It's a little bit easier to do than before when we had to plug the point and the slope in and solve for your y-intercept. This is a little bit easier to do because you're just plugging in a slope and a point. The downside is we're not able to graph from here. We'd have to actually turn it into slope-intercept form. But this does represent an equation of this line.